Hello, welcome to Wagner Academy, lesson 3.3 for geometry, slopes of lines. Now, slopes of lines, this is a subject that we talk about in algebra and even pre-algebra, but we're going to talk about it again here in geometry because, hey, we talk about lines in geometry. It's important to know the slopes of lines or how lines relate to each other on the coordinate plane as well. And some new terminology here, make sure you know these things, or some review terminology if you've taken pre-algebra, algebra 1 and talked about slope there, and use those extra examples in your book for additional help with your assignment. Now, slope, we use the letter M to represent slope. I was doing some research on this recently and really couldn't find a definitive answer why we use the letter M. Just know that that's what we use to represent slope, the letter M. We also talk about slope as, you may have heard of this before, but rise over run. And we can think of that in these terms as well. y2 minus y1 over x2 minus x1, and that's really the same thing as saying the change in the y values, so the change in y over the change in x. So all of these are legitimate ways to think about slope. When I say rise over run, I mean how much does it go up or down by, just kind of like the sun rises and sets going up or down, and then running, usually run back and forth, so how much does it go left or right by. Now, if you've never really gotten slope or understood slope or had a hard time with it, I'm hopefully going to explain it in such a way that it clicks with you finally, that it makes sense. So first of all, I like to think about slope in terms of what's going on over here. Yes, Mario 1. So here's a sloped incline, and if this is Mario 1, the original, I don't have Mario in here, here's his little hat and his mustache right there. Okay, so he's running and he's going uphill here as he moves left to right on the screen. If you're going uphill, I would think of that as a positive slope. So whenever I see lines that are graphed on a coordinate plane, that's how I initially think about slope. Well, is this positive or negative? Clearly this one's going to be positive because you're going quote unquote uphill as you move left to right, and you're going downhill as you move left to right on this one. And so let's talk about the two different ways from a graph that we could figure out slope. We can think about it like this, change in y over change in x, or we can look at the picture, pictorially think about how much does it go up or down by, and then how much does it go left or right by. So first of all, let's pick a couple points on this line that are clearly on the crosshairs here. So I've got a point right here that I can see is clearly on the crosshairs on the grid lines, and I've got another point right here. So if I label those points, this one would be -3, -3. This one would be 0, and -1. And I like to go left to right. It just makes slope that much easier, or maybe I shouldn't say that much easier. It makes slope easier. It might not be the easiest thing for you in the past, but hopefully it will become easier as we talk about this again. So think of slope, if we think of it as rise over run, I think about, okay, moving left to right, I have to go up to this level, then I have to go over to this level. So notice I'm using a different color here. I think it's a good idea. You don't have to use a different color, but I think it's helpful. So this would be a rise of 2 right there, and a run of 3. We're going up 2 and right 3. So let's fill that one in first. So this one, got the rise and the run. I'm going up 2, that's a positive 2, and I'm going right 3, that's a positive 3. So this would be 2 over 3. Now if the line is graphed, I think this is the easiest way to calculate slope, just thinking about rise over run. If you don't have it graphed, then I think, depending on whether or not you have graph paper available or if you want to graph it, then I think sometimes this is easier. This one is graphed, so I think this one is easier. However, we could do this way as well. So I like to label my coordinates. I usually start with the left point as x1, y1, and the right point as x2, y2, my first x and y, and my second x and y. If you label them clearly, then it makes it very easy just to plug them in and figure out, simplify the fraction, figure out what it equals. So I've got y2 minus y1, that's -1 minus -3 on the top. Notice sometimes you have a minus a negative. The form itself has minus signs in it, so if you have a negative number, you have to subtract a negative. And then x2 is 0 minus x1, that's negative 3. So this would become negative 1 plus 3, which would be positive 2. And this would be 0 plus 3. Two negatives will make a positive. That would become positive 3. So either way you look at it, you get the same answer, 2/3. So on this one, let's do the algebraic way first on this one, and then we'll check out a rise over run way second. So I'm just gonna find 2 points. Looks like this one is on those crosshairs, on those grid lines, and it looks like, oh, I saw one here. Looks like there's more than that. Could you pick other points than what I picked? Sure. It's going to work out just fine as long as you pick 2 points that are actually on the grid lines. So this one looks like negative 3, 4, and this one to me looks like 1, negative 4. So let's label those. This one would be x1, y1. If I want to go left to right, I think that's always the easiest way to go about it. It just keeps things simpler that way, going left to right. So we have negative 3, 4 for x1, y1. We have 1 and negative 4 is x2, y2. Plug it into the formula, the slope formula there. We have negative 4 minus 4 over 1 minus negative 3. If we simplify that, I have negative 8 on the top over, this becomes 1 plus 3. That would be 4 on the bottom. That means you have a slope, if you simplify that fraction, of negative 2. We could say that's the same thing as negative 2 over 1. So let's see if that matches up with what we have over here for rise over run. So if we go left to right, this time I'm going down first, so a negative value first, and then going to the right after that. Let me make that a little better there. Going to the right after that. So what is this value from here down to here? Well, I'm starting at 4. It's going to take 4 to get back to the x-axis, and then 4 more to get to negative 4. So that's a total of 8, a drop of 8 right there. And then we're going to the right, going from negative 3 to 0 would be 3, and another 1 would be 4. So this is, looks like a negative 8. We're dropping 8. So that's a negative value over 4. We're moving to the right 4. That's a positive 4 then. So this would simplify to the same thing. We should expect to get the same thing. It's just a different way to calculate or do the same problem. All right. So hopefully that is clear. We're going to check out a couple more now with horizontal lines and vertical lines. Still thinking about it both ways. And then later on, do you have to do both ways? No, absolutely not. You can pick one of the 2 ways, but I wanted to show you both ways, and you get to figure out what you feel most comfortable with. Make sure you know how to do both ways, of course, but figure out which one you get more comfortable with, so that if it's your choice, you pick the one you're more comfortable with. This one, negative 3, 2, I could pick any point along this line. All the y values along this line are 2. This is the line, y equals 2. And so I'll go with this one. So this is 2, 2 right here. And again, the y value is always 2. So that should make sense. We've got x1, y1. If I go left to right, this is x2, y2. And what's my jump here? I don't have a triangle that I could make like I had before here, because I'm just going straight over. So there is no rise. There's just a run part. I'm just going here. That's a jump of 5. And so this would become rise over run. I'll do rise over run first this time. So the rise is 0, and the run with these 2 points, considering these 2 points, is 5. Now I could think of negative 3, 2 and negative 2, 2, and then the run would be 1. But 0 over 1 is still the same thing as 0 over 5. It's still going to be 0 in the end. So 0 slope or no slope is what we could also call that. So here I could have picked actually this point and said go down to right 1. That's the same thing as negative 2. I could have picked this point and this point. Go down 4 and right 2. That's negative 4 over 2, which simplified is the same thing. So it doesn't really matter what points you pick as long as you pick 2 valid points. in terms of y2 minus y1, let's see what we would get. With these values, you'd have 2 minus 2 over 2 minus negative 3 with the values I had there. This would become 0 over 5, which is 0. So both ways give you the same answer, as we should expect. On this last one, why don't I go with, I'll go with this point right here, negative 3, negative 3, and I'll go negative 3 and 1. Here, this is the line x equals negative 3, because the x value is always negative 3. And so this one, I could say this is, I'm going to label that negative 3, negative 3. This one, negative 3, 1. Label the points. And on this, there's really no leftmost point, so I'll just call this bottom one x1, y1. And I'll call this top one x2, y2. So usually I go left to right, but if it's a vertical line, there is no leftmost points. So from there, I went with this one first last time. I'll go with the algebraic method first on this one. So 1 minus negative 3 over negative 3 minus negative 3. This will become 1 plus 3, which is 4 on the top. Negative 3, this will become plus 3. Negative 3 plus 3 would cancel each other out. You'd have 0. A number divided by 0. Think about dividing a group of things into 0 parts. It really doesn't make any sense. Your calculator even gets confused when you type it in, because it says that it can't do that. It's basically says error, or I don't know what you're talking about. I can't do that. Undefined. So this is an undefined slope when you have a vertical line. Rise over runway, same idea. Change in y over change in x. So we are rising. If I go from this point to this point, it'd be a rise of 4. And then the run, I'm not going left or right at all. That'd be a run of 0. So this, I could put a 4 right there. And same thing happens. So 4 over 0. What is that? I don't know what that is. That's undefined. Can't divide a number by 0. And then rate of change is very closely related to slope, because it's basically describing how a quantity is changing over time. So if you have something like this, maybe for every 2 things you get of one thing, and then you get 3 things of another thing, that would be the rate of change. Maybe you run 2 miles. Now that'd be a really slow run. Maybe you drive in a car 2 miles in 3 minutes. Every 2 miles you go 3 minutes, something like that, a rate of change. So we're going to apply that to this problem here. Example 2, India is expected to become the world's most populous country in the year 2025 and is expected to reach a population of 1.6 billion in the year 2050. It's expected to surpass China around that year. If its population was 1 billion in the year 2000, in the year 2000, if you don't know what that's from, Conan O'Brien, and has increased at a constant rate, calculate the expected population in the year 2042. So this one, we have a rate of change problem. We're trying to figure out basically how many people is the population increasing by each year. Once we know that, then we can just multiply that by a certain number to figure out what it is in 2042, in 2042. So rate of change, when we're talking about population, this would be the change in population over change in years. So we're looking for how many people per year is the population increasing by. We are getting to 1.6 billion. So in a sense, this number right here, this is like my y2, my second y coordinate. And then this number right here, in a sense, is like my y1, my first y coordinate. And then I'm talking about 1.6 billion in the year 2050. So this would be x2. This coordinate goes with this one. In the year 2000, that's going with 1 billion, this would be my x1. So if I think of it like that, then it probably makes it easier to plug into the formula, our slope formula. We have y2 minus y1, so 1.6 billion minus 1 billion over, and then x2 minus x1, 2050 minus 2000. This is going to give me the rate of change. If I subtract those two numbers, I would have 0.6 billion over 50. Now I'm going to write this as a whole written out number. What is 0.6 billion? That's 600 million. So this would be 600, it'd be 600,000. This would be 600 million. So increasing by that many people, 600 million people, that is just crazy. It's very congested in India, and it's going to get even more congested as more and more people are born there. So we have this number divided by this number ends up being 12 million. 60 divided by 5 is 12, so that should be possible to do without a calculator. But this is people per year. So that's the amount it's increasing by per year. So this is important, but it's not our final answer. I'll circle that for that reason. And then our final answer then would be, so in 2042, that's what we're looking for. What's the population expected to be if it's changing at a constant rate? That's a pretty big assumption. Usually populations grow more exponentially or on a slight curve. The more people you get, the faster things start to grow. But we're going to assume a constant rate for this problem. So in 2042, we've got 1 billion is what we started with in 2000. And to that, we would be adding 12 million people per year. So we would add 12 million times 42. 42 is 42 years after where we started, 2000. So this number right here, coming from there, and then 42, this is coming from, make that arrow a little nicer there, this is from the year 2042. This is 42 years after 2000. In the year 2000. And so this would equal, if you work that out, this, I did it in a calculator earlier, I have 1,504,000,000. That's a lot of people. So we have this many people. If we were going to write that in terms of billion, go back to the way it was written before, we could say that's 1.504 billion people. I would definitely like to visit India someday. I haven't been there. However, I'm just a little worried I might get trampled if there's that many people there. That's crazy. All right, two non-vertical lines have the same slope if and only if, so this works both directions. You can say if they have the same slope, they are parallel. And you can say vice versa. If they are parallel, then they have the same slope. Two non-vertical lines are perpendicular if and only if their slopes are. I prefer to think of it like this. I think this makes, from my experience with working with students over the years, I think this makes more sense to more students. So I say opposite reciprocals. Our book says equivalently lines are perpendicular if and only if the product of their slopes is -1. So you can think about it either way, but I'll probably talk more about opposite reciprocals than product of the slopes being -1. So example 3, determine whether line PQ and line XY are parallel, perpendicular, or neither. Let's, on this one, do a graphic method. So we've got a part A and a part B to this. Let's write that down right here. So this is going to be the graphic method, a graphic way to do this kind of problem. And then we'll do an algebraic way in part B. So this one, I've got these points given to us. I'm going to plot those points. So let's see what we got. We've got negative 4, 0. That's right here. And in this case, I'm just going to write P and not write the whole coordinate after that. I can just look back here as needed. Q is negative 1, positive 1. So here's Q. And X and Y, we got 1, 5. That's going to be right here. And we have 3, negative 1. That's going to be right here. So here's my X. Here's my Y. And I would get something like a ruler or some kind of straight edge to draw a line in with from here. So it looks like I'm going up 1, right 3, up 1, right 3. That pattern would continue with slopes. So I could start right here. I'm going to write this in my normal color. So I know I would have a point there. And continuing to go up 1, right 3, up 1, right 3. It needs to stay going through those points right there. Okay, and I'll put little arrowheads here and here. And then this one looks like I'm going down 1, 2, 3, 4, 5, 6, and over 2. So down 3 or down 6 over 2. That pattern should continue. That's off by a little bit. So down 6 and over 2 would be the same thing as down 3 and over 1. So down 3 over 1, down 3 over 1, down 3 over 1. That pattern continues this way, and it would continue going up this way as well. So we found, I've already verbally talked about the slope, but let's write that in there. We've talked about the slope, what it is. Maybe you just didn't realize it. So from P to Q, start from the left point and go to the right point. I think that's easiest. We're going up 1 and right 3. From X to Y, we're going down 6 and right 2. So let's write those numbers in. This was a 1 and a 3. This is a 6 and a 2. And so from that, it's easy to calculate the slope. So the slope of line PQ equals, thinking rise over run now, we're going, this is a positive slope. You're moving uphill as you move left to right. You're going up 1 and then right 3. That's 1 over 3. And then the slope of XY well, that's going from left to right. We're going down 6 and then right 2. So that would be negative 6 over positive 2. That would be negative 3 over 1, or just negative 3. Now I wrote it like this because I think it's easier to see that this one in that form, being those two in that form, would show that, are these parallel? No, they don't have the same slope. Are these perpendicular? Yes, based on what we set up here, they have opposite reciprocal slopes. And looking at the graph, it appears they are perpendicular too. Remember though, you can't trust appearances in geometry unless you're told that you can, or unless you can prove that it's true. We just proved that this was true, that these are in fact perpendicular. Yes, they look like it, and yes, they in fact are, because their slopes are opposite reciprocals. So slopes, let's write that down, are opposite reciprocals. You can abbreviate that like that. So they are perpendicular. The two lines that we were given the points for. So these are perpendicular. This is a graphic method. So if you have a graph or graph paper, this is a good way to do that sort of problem. You can do a problem like this algebraically as well. So let's do that algebraically, an algebraic method with some different numbers for part B. So algebraic method, that's what we got going on in this one. So let's label these first of all. So I have, this is going to be my first x1, y1, and first x2, y2. This is a separate line from this one. That's why I've added that little line in there, that little segment in there. This would be x1, y1 for the line xy, and this would be x2, y2 for that line. So let's figure out, based on that, what's the slope of PQ, and what's the slope of XY. So this is y2 minus y1 over x2 minus x1. We're going to use these numbers first. This is talking about P and Q. So we have -3 minus -4 over 1 minus -1. This would become -3 plus 4, which is 1, and this would become 1 plus 1, which is 2. So the slope of PQ is 1/2. The slope of XY would be 3 minus 1, y2 minus y1, over 1 minus 0, x2 minus x1. So this would become, this looks like it's 2 and 1. That would be the same thing as 2. However, looking at this is, I think, better when we're thinking about whether the slopes are parallel, perpendicular, or neither. So yes, it does equal -2 in the end. What does this mean, though, for the problem that we're talking about? Is this parallel, perpendicular, or neither? Well, I see this mistake a lot. Students will look at this and say, oh, they're reciprocals, they're perpendicular. Wait a minute. They got to be what? They have to be opposite reciprocals. So one has to be positive and the other one has to be negative. So if you were to graph these, one of them would just look like, I'll just do this off to the side, one would be kind of like this, and then the other one would be more like this, but they wouldn't be perpendicular, and they definitely wouldn't be parallel either because they don't have the same slope, but that would not be a 90-degree angle. So this one is neither. And we could say that the slopes aren't opposite, or are not opposite reciprocals. So that's the difference there. That's why I did one like that, where you had reciprocals but not opposite reciprocals. And then finally, example 4, graph the line that contains z at -2, 5. So -2 and then 1, 2, 3, 4, 5. That would be right here. Here's point z. And is perpendicular to line AX, with A being at -6, -6. So it's 3, 4, 5, 6, and then down 6 would be down to here. And X is at -1, -3. So that would be right here. So here's Z. I'm going to label the coordinates on this one with the whole thing. This is -2, 5. This is A at -6, -6. And right here we have X at -1, -3. And so let's connect these with a line. So it looks like I'm going up 3, right 5. So that pattern would continue up 3, right 5. And I got to go up 3, right 5 again. So I'd have another point right there. And so if I connect those through those, that should be a good line. We're good to go there. That would continue going that way, that direction. And so this one needs to be perpendicular to that line. So based on what I have in this graph here, I can't say exactly where that is yet or exactly where that line is going to be until I calculate the slope of this one. So I have already hinted at the slope. Maybe you caught that. I said go up 3, right 5. That's exactly what we're doing here. So this one I'm using a graphic method instead of an algebraic method to calculate the slope. But the slope of AX, line AX, clearly from the picture, is we're going up. How much is this? This was 3. And then we're moving from left to right, up 3, right 5. So we have +3 over +5. I'm writing the positive signs and negative signs. You don't really have to write the positive signs. You definitely have to write the negative signs. But just showing you that up is positive, right is positive. So this is +3 over 5 for the slope of this one. What does that mean about the slope of the line containing z that would be perpendicular to this? Well, it has to have a slope that's an opposite reciprocal of this slope. So that means the slope of, and you can use this symbol, remember, for perpendicular. It's kind of like an upside down T. So the slope of the perpendicular line would have to be -5/3. So from here to here, these are opposite reciprocals. Yeah, you could think of the product of their slopes being -1, but I think you probably can see why I usually say opposite reciprocals. It's just easier to think about. So as we graph this, I'm going to do this in a different color because this is just kind of like a note as to what we did. You wouldn't have to write this down. You can if you want. So start at Z. So we're going to start here, and then we're going to draw a line with a slope of that, with a slope of -5/3. So start at Z and draw a line with a slope of -5/3. So that is what we're doing to finish up our problem here. So -5 down 1, 2, 3, 4, 5/3. 1, 2, 3 would be right here. That pattern would continue. I'll draw in one more point here. 1, 2, 3, 4, 5. 1, 2, 3. Here would be another point. And if we finish our problem up here, we're going to have a line going, and I think I want to move, well, might be a little too late for you, but I'm gonna move that a second. Never mind. That'll be fine. I'll just go right through the point. Not a big deal with my line. So this coming here, coming here. Typically I don't like to go through what I wrote with my line, but that's okay. So this goes that way and that way. This then would have to be perpendicular here and here. So this would be perpendicular. We've got 4 right angles. Remember when we have perpendicular lines. And oh yeah, this, what is this going on over here? This is actually something called a Zax. This is a specialized tool that roofers use. One time I played this in Scrabble and I had no idea it was actually a word, and had it on like a triple point score thing, and just put it down kind of as a joke, and they challenged me, my friend challenged me, and I got it right, and I think we ended up tying because of that, and he was not very happy with that, but I was definitely happy. All right, so we've got a good review from algebra. Hopefully you remember a lot of these things from algebra and pre-algebra, but review the video as needed. Make sure you know these terms, and as always, have a great day. I'll catch you later.